Welcome Form 4 at Maths Past Years SBP. Topic Coordinate Geometry. Diagram 13 shows the straight line BC over here, straight line BC, and the straight line BA over here, BA, which intersect at point B. Both lines are intersecting at point B. We are given the equation of the straight line BC is 3y minus 2x equals 5. So we are given the equation of the line BC. And the angle ABC is 90. Now this information, angle ABC, ABC. So which means this angle, this angle is 90. Which means the line BC and BA are perpendicular. Later we will use this. Next, the straight line AB intersect that exists at point 40. So the straight line AB is intersecting the x-axis at the coordinate 40. So I have completed the diagram. We look what is the question asking. Part A. Find the x-intercept of the straight line BC. As usual, we start from what they ask. Part A. They are asking the x-intercept of the line BC. Now, if x-intercept from lower secondary, the y must be 0. At x-intercept, the y coordinate is 0. So now we take the y coordinate 0, we substitute in the equation of the line BC, which was 3y minus 2x plus 5. Now, this was given to us. So in this equation of the line BC, we substitute y0 because of x-intercept, y0. And what we will get? So the y, I substitute with 0. So that becomes 3 times 0 minus 2x equals 5. So I have, of course, 3 times 0 is 0. I have negative 2x equals to 5. I transfer the negative 2 to the right hand side, becomes divide. So I get x equals negative 5 over 2. Our first answer. Second, part B, find the equation of the straight line AB. They are asking the equation of this line AB. So here, as usual, part B, we start from what they are. They are asking equation of the line AB. Now to find equation of a line, we need the gradient of the line and a point on the line. Here, to find equation of line AB, therefore I need the gradient of AB and a point on AB. In this question, we already have the point on AB, which was the point A over here. So point is already given, the point A 40. So now only we have to find the gradient of AB. And AB, the line AB, is perpendicular to the line BC. This was given over here. The line AB is perpendicular to the line BC. Because of this, 90 degrees. And we know from our notes that when two lines are perpendicular, so the gradient of one line equals negative 1 over the gradient of the other line. So here gradient of AB, negative 1 over gradient of BC. So in order to find gradient AB, we need to find gradient BC. So to find gradient BC, got two methods. Either use the formula of gradient, but for this, you need two coordinates. On the line BC, we don't have two coordinates on the line BC. We don't have any points on the line BC. And another way to find the gradient of BC, is from the equation of the line BC. So remember, to find gradient, got two methods, either formula or from equation. Here, in this question, for the BC, we already given the equation of BC, which was 3y minus 2x equals 5. And to find the gradient, this equation BC, you must change it to the format of y mx plus c. Then only we can get the m gradient. So what am I doing now? I will take the equation of BC, change it to y mx plus c. So for that, of course, I have to transfer the negative 2x to the right hand side. It becomes 3y equals 2x plus 5. And then I have to transfer the 3, I have to transfer to the right hand side, which means each term, 3y, 2x, and 5, I'm going to divide by 3. So 3y divided by 3, I'm going to get y. And then 2x divided by 3, 2 over 3x. And finally, 5 divided by 3, 5 over 3. So once you have this format, of course we know that the 2 over 3 is the gradient of BC. So the gradient of BC is 2 over 3. We take this gradient BC, put back in the formula just now. Gradient AB is negative 1 over gradient BC. Okay, don't forget, this formula was already mentioned here. So I'm just rewriting back the formula, that's all. So I'm going to substitute gradient BC, which was 2 over 3. And of course, 2 over 3, you bring it up, becomes 3 over 2. So the gradient AB is negative 3 over 2. So now we have the gradient AB. We have the point A, which is 4, 0. We will substitute in the formula for straight line, which is y minus y1 equals to mx minus x1. We are going to substitute the coordinate y1, 0, x1, 4. So it is y minus 0, and then because the y1 was 0, and then the gradient m, negative 3 over 2, over here, negative 3 over 2, and then x minus x1, and the x1 is 4, therefore 4 x minus 4. Now the first thing is here, on the left hand side, y minus 0 is of course y, but I took the 2 right hand side, I went to the left hand side. So 2 times y, that will give me 2y equals right hand side, negative 3 brackets x minus 4. So on the right hand side, I'm just going to expand. Negative 3 times x is negative 3x. And then negative 3 times negative 4, be careful, positive 12. In order to get straight line, it is better to transfer everything and make it 0. So the right hand side, I transfer to the left hand side. Finally, I'll get 2y minus 3x transfer plus 3x, plus 12 transfer minus 12 equals 0. So our answer for the, which here, equation of the line AB, it was 2y plus 3x minus 12 equals 0. Thank you. I see you on the next lesson.